Hi, everyone. Today I'm going to tell you a little bit about how we got to compile the standard library with gccrs. The first thing I want to make clear is we didn't do it. Actually, a better title would probably be miscompiling the standard library with gccrs. You also have failing the standard library with gccrs, since we're disappointing it a little bit. We can also do piling on the standard library with gccrs, because we do yell at it quite a bit and quite often. So yeah, first, a little bit about myself. Who am I? I'm a compiler engineer at mbcosm. It's a small company based in the UK. We work on compiler backends, mostly in open source, so GCC, LLVM. I'm the co-lead of the GCRS project with Philippe Heron. I'm one of its 2 maintainers, and I'm French. I live in Paris. And this is a picture of my dog because it's much cuter than me. So yeah, what is GCRS? First of all, GCRS isn't. So what GCRS isn't, and GCRS is not yet an alternative implementation of a Rust compiler, but we tried to do it. We're trying to do it from scratch. So basically, we implement an entire Rust compiler from scratch. The project was started in 2014. As I've been discussing with a lot of people since yesterday, yes, we are writing it in C++. No, I don't know why that is. Yes, I hate it every day. That was started almost 10 years ago. There will be a rewrite eventually, but for now it's C++. Sorry about that. It's a reimplementation within GCC. So if you don't know GCC, GCC stands for the GNU Compiler Collection. It's a very old project of many compilers. It was started 35 years ago. It contains compilers for a lot of languages: D, Ada, Go, most notably C, C++, Fortran. GCRS targets the version 1.49 of the Rust programming language. So if you do remember that version, it was released in December of 2020. That was almost 3 years ago. A little bit later, I'm going to explain why we chose that version, why we're sticking to it. But I'd like you to keep in mind that this version was released 3 years ago. It's going to become important in the next few slides. And that work is funded by Open Source Security Incorporated and mbcosm, the company that employs me. There are 3 people currently being paid to work on GCRS. So myself, Philippe Heron, and my colleague, Pierre-Emmanuel Patry. And we have around a dozen or so contributors working for free on the compiler. So what does it mean to be a Rust compiler? And that's a very good question. And how the fuck should I know? I haven't made one. I'm trying to make one, but we're not there yet. What I do know is that we want GCRS to support the exact same feature list as rustc. So that means warts, bugs, features, everything that you expect from rustc, we want it to be implemented in GCRS. So the same features, same bugs, same test suites, and that goes both ways. So GCRS should be able to pass the rustc test suite, but rustc should also be able to pass the GCRS test suite. We don't want our test suite to contain some sort of alternative GNU Rust language that only GCRS understands and not rustc. So that's one of the goals. And another major goal is for us to have the exact same standard library as the official rustc compiler. So that means we want to just distribute std as the sources to std. We don't want to add ugly acts to make it work on GCRS. We don't want to cause some sort of pain in between the 2 compilers where both standard libraries are not going to work the exact same way in some very subtle details. So yeah. And what exactly is the Rust standard library? And it's a lot of things. Most importantly, it's composed of 2 crates, which are core and alloc. Core is the crate that's going to provide the, unsurprisingly, core functionality of Rust. So you're going to have your option type, your result types, everything, and your functions and types that are really intrinsically linked to the compiler. Funnily enough, a lot of them are called intrinsics. So yeah. Finally, a Rust compiler should be able to compile Rust for Linux. So we want to be able to provide Rust for Linux support. This is one of the reasons why the GCRS project is currently funded. One thing I will note is the CodeGen GCC project, which is different from GCRS. The CodeGen GCC project is being worked on by Guillaume Gomez and Anthony Boucher, and they can already compile Rust for Linux. You should go and use that compiler, not mine. You should fund them. They are much more advanced, much more likely to succeed than us, and they're doing an amazing job. So go ahead and work with them, fund them. They will be very thankful. And one of the things that GCRS will provide is the ability to reuse GCC security plugins, which work at the GCC intermediate representation level. So over the years, as you may know, people have been writing very, very bad C. And that's been going on for dozens and dozens of years. So one of the alternatives, instead of writing good C, was to develop compiler plugins to catch the bad C and make sure, well, it errors out. So there's a lot of static analysis passes in GCC itself, and there's a lot of plugins that work on that GCC intermediate representation to catch those category of bugs. And one of the cool things about GCRS is we can reuse these plugins and these static analyzers to work on Rust code as well. As you may know, there is something called unsafe in Rust. It's very fun, and it's the cause of a lot of issues. And Rust does not protect against every class of bugs out there. For example, if you forget to close your file descriptors and so on. And because C programmers have been forgetting to close their file descriptors for 40 years, well, there's a lot of good plugins to catch that. So yeah, it's going to provide language-agnostic security features, and we're going to be able to reuse the static analyzer from GCC on Rust code as well. And we have started doing that on some small parts of core, so the parts we can compile, and trying to see if we can catch some logic bugs in the handling of file descriptors or memory allocations and so on. And yeah. So what do we need to build STD, the standard library? And as I said again, we can't do that. So what do we need to build core, first of all? And yeah, we target the version 1.49 of core. But as you may know, the core library is a really, really fun testing ground for new compiler features. So even though we target Rust version 1.49, which was released 3 years ago, we need to handle stuff such as declarative macros, which are not finished at the moment, and who have been worked on for, well, at least the past 3 years. Similarly, specialization, so a very powerful type system feature I don't understand. Well, you have some of that in the core, like in the core library in 1.49, and we need to be able to handle it in order to compile core, even if the stable language at this version does not support it yet. We also need a fully fledged out type system, so fun. We need to do name resolution properly. We need to do macro expansion properly, and that's the parts I've been working on, especially this year. And that means warts and all for name resolution and macro expansion. All of the interesting behaviors of Rust when it comes to name resolution and macro expansion, well, we need to support them as well. Finally, a bunch of compiler intrinsics. We'll get into that a bit later. So let's have a look at one little fun macro thing. As you may know, this is a function, pub_fn foo. It's got one attribute, which is the doc attribute, and the doc attribute allows you to specify documentation for a Rust item, in that case, a function. If you're using Rust today, that code is going to work, and it's going to show up as this is the documentation for foo in your generated HTML documentation file. But interestingly, if we try and run it with rustc 1.49, well, it doesn't parse. It doesn't even recognize that concat token. It doesn't even accept that that token can be right after the doc equal tokens. And that's for a very simple reason. It wasn't implemented. The issue is we looked at the Rust reference when we were implementing the doc attribute, and we saw, well, the doc attribute can support macros. So we implemented it. But now we're realizing that the version of Rust we're targeting does not support it. So we have to de-implement it. And if you try running it with Rust 1.51, so again, you can see how old that version is, 2.5 years old or so. Now it works, but it's unstable. And so yeah, there's a lot of issues that gccrs runs into, like, well, the Rust reference says this exists because it exists currently, but back then it didn't exist. But because we're too fast and don't pay attention, we implement it anyway because it's fun, and then we have to remove it from the compiler. And you can say, yeah, well, this doesn't matter. But we are very, very, very focused, and we do want to pay a lot of attention to not compiling a superset of the Rust programming language. We don't want gccrs to allow more behavior than rustc, because that would be bad for a lot of reasons. If we allow gccrs to compile a subset of the Rust programming language that Rust understands, then that's fine. That just means we're not an amazing compiler, but at least we don't allow more behavior that's going to cause pain to users in the future. And yeah, as I said, this is now stabilized. This is now all working. As Guillaume Gomez said to me yesterday, I did it because I was bored. So yeah, you can thank him for it. Now, another little word. If you don't know about this, this is a declarative macro, so a macro 2.0 as it's called. And this is part of the core library. It's the ready macro. It takes an expression, it's going to check if it's ready or pending, and return based on that. And they are annoying to parse. They are especially annoying to parse when you've been working on parsing regular macros for 3 months and you discover you need to handle declarative macros as well. And one thing I want to point out is this little attribute. So I'm going to ask a question. I want people to raise their hands or not raise their hands. Who thinks that code compiles as of Rust today? Okay, one person, good. And does that, like, who expects that code to export macros just like regular ass macros, even though it's a declarative macro? Okay, so not a lot of people. And the truth is, well, macro exports for old macros and for new macros does not work the same way at all. So the old macros have a lot of very fun behaviors, and they're actually not they're not exported like regular items, but these work exactly like regular Rust items. So we do run in situations, for example, this was not the exact macro I had to fix in the core library, but some macros in the core library were still had the attribute macro export, and the compiler was not warning on them or anything. So when we, as gccrs developers, were reading the core library, well, we were seeing those attributes, and we were wondering, well, do we need to export them just like regular macro? If they got the macro export attribute, are they exported similarly to pub macro items? So yeah. Another interesting thing, so this creates a module foo, a module bar. There's going to be 2 macros in it, mac and maxported. Maxported has got the macro export attribute. And then from our main function, we're going to call mac and maxported from the foo and bar module. So again, show of hands, please. Who thinks that Rust code is correct and compiles? OK, so either you think it's not correct, or you don't know a lot about macros, and you're lucky. And yeah, that code does not work, actually, because macro rules, and so these called macros by example, well, their name resolution does not work at all like regular items, as I've been saying. So these 2 macros are going to be visible in the textual scope of the bar module. So right after the last macro definition, we're going to be able to call both of them. And the macro exported one is also going to be visible from the root of your crate. Okay, but both of these macro invocations are not correct, and they're going to fail. And the compiler is just going to tell you, well, I can't find mac in foo bar, but mac is right there. I can't find maxported in foo bar, but again, it's right there. So at this point, you have 2 solutions. You can either ping Esteban on Twitter and tell him, well, this is borked, please fix it. Or you can try and work with the amazing people from the working group on macros and try and fix it as soon as I have time, which is coming. Yeah. So what do we do with all that? We have 200,000 lines of C++11. It must be useful for something other than segfaults. And interestingly, the Dreamcast homebrew community started relying on gccrs to try and allow Rust code to work and run on the Dreamcast console. Because the LLVM backend that rustc uses by default does not handle the super H4 architecture thingy, so they have to use gccrs. Once again, they should use rustc gen GCC, but they're maniacs like us, and I think they ran into some issue. And yeah, gccrs can also provide static analysis of unsafe Rust code, as I said earlier, and reuse GCC plugins. Figuring out the unspec stuff, those slides are not finished, allows us to add to the spec. So the spec sort of effort that's currently going on in the Rust community, well, the gccrs people want to be a part of it, and they want to help reviewing it. They want to help in saying, well, the ref made Philip cry for 6 months. Maybe if it was explained a lot in the spec, it would help sort of also, it would help other rustc compiler devs. Macro name resolution as well. So this was a tweet saying, for historical reasons, the scoping of macros by example does not work entirely like items. Has been kicking my ass for 3 days. This was in September of 2022. It's still the case today. This sentence is at the beginning of the section on macro name resolution in the Rust reference. And yeah, macro name resolution is fun. All right, so what does the future hold? First of all, async await. As you know, async await is available in Rust 149, so that means we have to support it. And one of the reasons we chose Rust 149 and not Rust 150 is that Rust 150 allows const generics. And we were like, well, const generics sound hard. We don't want to do them, so we're going to target Rust 1.49. The issue is a very simple rib grep in the core library for version 1.49 of the compiler shows that const generics are already used. So we do have to implement const generics, actually, and we do have to support them in order just to compile the core library again. And this isn't like a fancy regular expression. This is just the most basic as const generic you can stick in Rust, and there's hundreds of them. So yeah, they're in core anyway, and anyway, one of our GSOC students could reuse the C++ front end to do some constant folding. So we're most of the way there, but yeah. Then, Formatargs. Formatargs is a very fun built-in macro that needs to parse and handle a lot of format specifiers and is able to format your strings. This is an interesting macro because it's the one that's used by println. What this means is that you still can't do hello world in gccrs. I'm working on it, and as soon as Formatargs is working, well, we'll be there. But yeah, at the moment, this is not the case. We also have all the super fun intrinsics that LLVM has, but not GCC. So a lot of compiler intrinsics that rustc has and uses, well, they're not available in GCC, so more work for us to implement them in GCC. Finally, a very, very, very important part of what we need to do is to implement a borrow checker for gccrs. As I said again, we don't want gccrs to be used as an escape hatch to allow more features to the Rust language, or people to use a sort of GNU Rust to compile their invalid Rust code that wouldn't work with rustc and so on. So we do want a borrow checker, and I've been pestering LQD and Nico Matsakis about reusing Polonius for months at this point, so it's going to happen soon. Yeah, finally, gccrs does not want to introduce breakage to the Rust ecosystem. As I said, this is something super important to us. We don't want to cause any pain to upstream crate maintainers. We don't want to cause pain to Rust developers. We don't want to put pressure on anyone, and we don't want to step on any toes. We're foolish enough to work on this. Doesn't mean you guys have to suffer for it. So yeah, no pressure on crate maintainers, even if it gets us some backlash. I'm going to show you a little bit of a backlash we got. So at the moment, if you want to try and do anything with gccrs, you have to pass that very annoying flag, which says, this is incomplete and experimental, and it's a compiler, but not really, and you should not use it. Otherwise, you get this very annoying error. The text did not fit on the slide. It tells you to report a bug. It tells you that what you're trying to compile is maybe correct, but we're not handling it. So whatever you do, do not pester crate maintainers. Come and report a bug to us. We will take care of it. Do not annoy the nice crate maintainers because it doesn't work on gccrs. Okay? Then, what else can we do? We want to catch up with Rust for Linux. So gccrs is funded partly because we want gccrs to be able to compile the Rust for Linux Rust code. Once we have implemented Rust 1.49, we can work on adding some of the features that Rust for Linux needs in order to catch up to them and have two compilers be able to support Rust for Linux. This helps spreading Rust adoption because there's a lot of very annoying people in the Linux community that want their kernel to be compiled only by a GNU toolchain. So yeah, we can help with that a little bit. In the future, we also want to pay special attention to respecting the Rust semantics. So we got contacted by some people on Zolip already, like Ralph, asking us how we plan to handle this and that. And I'm very happy and very thankful that they got in touch with us, because we do want to get in touch with the community, and we want to ask all of the people here, we want to ask all you folks for help for how to compile proper Rust code to proper assembly that doesn't introduce unsoundness or anything fun. So yeah, we really want to do things correctly. And finally, we're going to spend a significant amount of time upstreaming patches, because as you may know or not know if you're lucky, GCC development is still mailing list based, so at least a third of my time is being spent writing emails and replying to emails and fucking up my get send email commands. And yeah, thanks to all the people who made it possible. Actually, thanks to the people who haven't yet made it possible, but they're working really hard on it. So Open Source Security for funding that work and funding that talk, and Becosm for funding part of the work as well and sending me here to annoy you with my stuff. From the Rust community, a special thanks to Bjorn, Philip Krones, Guillaume Gomez. These people have helped us tremendously. They've been providing advice, issues, yelling at us when we do something bad, and they're super helpful. All of our contributors from the GCC side, so Thomas Schwinge, Mark Polias, they wanted to be here, they couldn't be here. And so many more. As I said, we got around 12 to 15 regular contributors at the moment, and most of that is unpaid work, and we really, really appreciate it. Finally, a couple links. So our GitHub, our blog, our Zolip, you can join it. Our IRC, which is quite active. Our mailing list, don't use it, but you can look at it if you want. And any questions, which I've been told happen on that side of the scene. So yeah, thank you.